Hi everyone, and welcome to this tutorial on TC10 Wake and Sleep Mode in automotive ECUs. In this video, we will specifically focus on using a network of 4 DP83TC812 EVMs to comply with the Open Alliance TC10 standard. Both the wake and sleep sequence will have crucial indicators and requirements for the Ethernet PHYs to be TC10 compliant. Let's get started. We will start with an introduction of what TC10 is. TC10 is an automotive Ethernet standard that defines a sleep mode and wake-up mechanism. This standard is useful for automotive applications because modern vehicles rely on partial networking for lower power consumption, lower ECU temperatures, better fuel economy, and minimal battery power consumption. Let's cover some important requirements for an Ethernet PHY to comply with the TC10 standard. The idea behind TC10 is that systems can be shut down when not being used to save power and quickly woken up as desired. The basic energy detection functionality remains active on the PHYs. As you can see, the TC10 requirements are listed on this slide. TC10 defines PHY current consumption to be less than 35 microamps while in TC10 sleep. These sleep requests and wake-up pulses are exchanged over the Ethernet cable without needing a dedicated wake-up wire. These sleep requests will be initiated by the Ethernet MAC using software registers. The requesting PHY will then send a low-power sleep signal to its link partner. If agreed upon, both PHYs enter TC10 sleep and stop sending signals on the cable. The PHY can then be woken up by two methods. The first is a local wake-up, where the Ethernet MAC will drive the wake pin high on the PHY. The next is a remote wake-up, where the wake-up pulses are sent over the twisted pair cable. TC10 also supports wake forwarding to wake up downstream PHYs, and we will demonstrate this in lab. The system illustrated on this slide is what we will use to verify TC10 compliance when using the DP83TC812 EVM. This is an example of a compliant TC10 wake sequence that we will break down into steps. The first step is to wake up the host PHY from TC10 sleep. The MAC will send the wake pulse on the wake pin of the PHY to do this. This causes the PHY to drive its inhibit pin high. PHY 1 will then send a wake-up pulse on the automotive cable to PHY 2. PHY 2 will then send a wake-up pulse on its wake pin and forward it to PHY 3. Then PHY 3 sends remote wake-up pulse on the MDI towards its link partner. The link partner detects the valid wake-up pulse and asserts its own inhibit pin high. Once both systems have powered up, a valid link is established by all 4 PHYs. As you can see, the current consumed by the DP83812 PHY is within the specified TC10 range, with a value of 6 microamps. To wake the system from TC10 sleep, a 40 microsecond pulse needs to be sent on the wake pin of PHY 1 from its respective MAC. Today we will simply pull the wake pin high using the available jumper on the EVM. This will simulate the MAC sending out a wake signal. An important thing to note is that when your system is in TC10 sleep mode, it is crucial to pull all wake pins low via the available jumper. This will prevent the links from re-establishing if a power cycle occurs. I will now pull the wake pin on PHY 1 high via the wake pin jumper. As you can see by the LEDs, all links are established on all 4 PHYs. Now we will move on to the TC10 sleep sequence, and again we will break it down into steps. The first step for the sleep sequence is that the host MAC instructs the host PHY to initiate TC10 via register access. The host PHY then sends a low power signal to its link partner. The link partner PHY informs its MAC of an LPS signal being received. The link partner MAC decides to allow link partner PHY to enter TC10 sleep. The link partner stops sending idles, the inhibit pin goes low. Then the host PHY detects that idles have stopped and enters TC10 sleep, and both inhibit pins will go low. Using the same setup in lab, we will confirm TC10 compliance using the onboard indicators when entering sleep. When putting our Ethernet system in TC10 sleep mode, you must write the hex value of 2 to register 018C on PHY 1. This register and value are specific to the DP83812 TI PHY. Before I write to this register, I will show you that the links are active and the current draw is the typical active current draw, with a value of 1.412 milliamps. I will now write the hex value of 2 to register 018C on PHY 1. As you can see by the LED indicators, the link is down and both PHYs are in TC10 sleep. This current draw of 5.9 microamps is compliant with the TC10 standard. In this demo, we have completed both a successful TC10 sleep and TC10 wake demo. If you would like to purchase the EVM used in this demo, please access the hyperlink in red. Thank you for watching.